Hey everybody, what's good? Welcome to the Daily Space Weather. Congratulations on realizing our channel exists. Let's get to it. There's a lot of stuff to cover once again. Coronal mass ejections. Some people think they're Earth-directed. Some people don't. Here's some composite imagery from the Solar Dynamics Observatory. Ionized helium and iron. Most likely place for major activity is from sunspot 2891, which has degraded but remains a beta-gamma class sunspot. Let's take a look at the viewpoint from Lagrange point 1, where the LASCO C2 and C3 are located left and right screen respectively. And we see some coronal mass ejections. I don't think they're Earth-directed. Some folks do. We'll have to wait to see what happens. I'll explain that in a moment. Again, those coronagraphs are located here at Lagrange point 1, the gravitational equilibrium point in between the Earth and Sun, where the SOHO spacecraft is located. The LASCO C2 and C3 coronagraphs. By the way, if you don't follow us on Twitter, you may not see my tweets, obviously. So perhaps consider getting on Twitter if you aren't, or if you already are. Make sure you follow. We put up a comment last night to Tamitha Scove. Tamitha, on this one, the model is missing a far side ejection, coronal mass ejection, and mistaking the far side component for an Earth side component. This also happened 2 inaccurate trajectory models ago. It might still have a small geospace impact regardless. Part of the ejecta may be Earth-directed. Most of it is not. This model does not include a far side CME on the opposite side of the Sun from the Earth. So there's a little Twitter exclusive for you, if you weren't aware that I'm on Twitter. And next, the colorized magnetogram. Sunspot 2891, again, it has degraded in the past 24. I think it's going to continue to do so today. I think it might be downgraded to an alpha class sunspot by the end of the day today. We'll keep an eye on it. Pardon the pun. Here's 1700 angstroms. And not particularly animated there. Let's move on to the radio flux, which is at 97 solar flux units. Yeah, the upper chromosphere and lower corona, this little area right here at the base of the Sun's, quote, atmosphere, end quote, puts out radio frequency. 10.7 centimeter radio flux. There's the black line there. That's the 1-year chart for the radio flux. The red line beneath it is the most proportional data set to solar activity, as we call it the sunspot number. So you can see some geomagnetic storms forecasted for the coming 3 days. Late tonight, expecting a G1 geomagnetic storm there, KP5 event, going out through most of the day tomorrow. Forecasting geomagnetic unrest and storms throughout the day tomorrow. I disagree with this forecast. I don't think those CMEs are barely going to produce any bit of a pulse on the solar wind data. We'll have to see who's correct there. It looks obvious that most of the ejecta is expected to miss Earth, but hey, that's the NOAA forecast. We cover it because it's the NOAA forecast. Next, I just want to show folks briefly here for a moment global seismicity. So when we're talking about an earthquake drought, the space between those red bars, those are 7 magnitude earthquake droughts. And we're currently seeing one. So if you're in an earthquake-prone zone, have a plan, know which building facades might collapse. Look at this long drought here in 2012. See what happened at the end of that long drought? It ended in a nearly 8 magnitude earthquake. So this is a normal thing, folks. Statistical analysis is one of the legitimate ways to forecast earthquakes. There are all kinds of illegitimate ways to forecast earthquakes that have people believing a lot of nonsense on YouTube. Look at the long drought in 2017. That's one of the longest ones on all of these graphs. Similar one there in 2018. Once again, followed by large quakes. A series. Quite a uptick there in earthquakes in 2018. Around when we started making the channel, actually. We're pushing 4 years of daily space weather videos. And let's get up to the top of the list here. There is the 90 days bar graph. You can see a bit of an earthquake drought kicking up. Let's see what's been going on. It's a bit of an uptick here in earthquake activity over the past 24 hours, including at least one Cascadia quake. A 4.4 near Petrolia, California. And I'm just going to scroll up the list here. If we miss anything, let us know in the comments. 5.0 at the Carlsberg Ridge region. Largest quake of the past 24, I believe, was this 5.7 at Indonesia there, north of Australia. That came in at 1643 yesterday on All Saints Day. By the way, happy belated All Saints Day, if I forgot to wish you a happy All Souls Day, rather, not All Saints Day. All Souls Day. Yes, you've got Halloween, then you've got All Saints Day, which is the Catholic answer to Halloween, then you've got All Souls Day, which is the Protestant answer to the Catholic answer to Halloween. All Souls Day. Fiji saw a 4.8 at nearly 600 kilometers estimated depth. Excuse me. And we saw here a Chilean quake. Two 5.7s occurring only 2 minutes apart across the Pacific Ocean from each other. There's a 5.7 at Chile at 110 kilometers and a 5.7 at Fiji at 35 kilometers estimated depth. Two quakes happening nearly simultaneously on opposite sides of the Pacific Ocean. Does it give us insight into the internal workings of the Earth? Well, probably, but I won't cover it in any more detail at the moment. It's a daily space weather video. Check out the sights and sounds of La Palma Volcano, erupting here in the Canary Islands. Quite a decent-sized ash plume from the volcano there on La Palma. And it's showing up first on the list. It's producing a significant plume of volcanic ash. Just don't fly your plane over it. Let's just say that. It doesn't list the size of it. I guess it's too cloudy. Who knows? Suminose-jima also exploding. 9,000-foot ash plume from Suminose-jima. Some volcanic seismic tremors occurring there as well. Manam now back on the list as it explodes. That's located on Papua New Guinea. 6,000-foot ash plume from Manam. Fuego exploding as well. 16,000-foot ash plume over Guatemala from Fuego. Volcanic ash not observed from Nevado del Ruiz. Don't assume it's not erupting. Sabancaya exploding. 25,000-foot ash plume over Peru. Please don't pole vault the caldera. Please do visit our links. You can find links to our Redbubble shop below the video. So click on that. These make great gifts. We're breaking out a little bit of humor here. Please don't pole vault the caldera, folks. We need the views on YouTube. We need you to tell your friends and foes about the channel, as I don't think the algorithms are doing it. Here's the Redbubble shop. This is organized by best selling. And again, you can find links to that at smashamash.com. Just click the smAsho merch link on our homepage at smashamash.com, and I would say to you, Universum Liberate. Let's look at magnetic data. Here is the last 3 days. And we're seeing pretty low readings here. By the way, these N's and M's, they stand for noon and midnight local time for the GOES 16 and 17. And we saw low readings at the magnetometer yesterday. There are coronal hole winds on the way to Earth, certainly, and some coronal mass ejecta flying around the solar system as well. I just don't believe it's directed toward Earth. Next, the heliospheric current sheet. And here's the current sheet. You can see Earth's potential field surface source line shown there in orange, completely within a North Pole-oriented current sheet. No changes expected in the near future for that. Keep in mind the magnetic environment can suddenly change with basically no warning. Here's the line of sight ecliptic plane field plot showing the solar magnetogram. The blue line represents some indication where the sun's B field is located, which translates to the BZ component, the top pane in the real-time solar wind data that we show daily. Pretty calm conditions at the moment. Here's a line of sight coronal hole plot, and you can see that green area there. That's a large series of rather diffuse coronal holes. They're not very well defined, but there is likely a strong solar wind coming out of those. This also shows you the sun's B field in blue. Those potential field surface source lines in blue are the sun's B field. Next, we've got another animation here. Some oddities going on with our Helio viewer movies today. I would just assure you that the area in the northeast, this area around here, is all North Pole-oriented coronal hole material. Or you could say a lack of material. Showing us down to the chromosphere. Anyway, here is the flare probability monitor and detected sunspot groups. Again, I think 2891 is going to degrade to an alpha class sunspot today, which will leave only, I think, two named groups, 2891 and 2893, as 2887 is setting in the southwest. Likelihood of major flares drops as a result of the degradation of sunspot 2891. We did see an M-class flare yesterday. It was a long-duration flare, and I guess it was associated with a coronal mass ejection. I mean, it certainly was. The question is it directed toward Earth or not? Let us know in the comments what you think. And please understand the difference between solar flares and coronal mass ejections. Solar flares are X-ray photons. Coronal mass ejections are protons, primarily hydrogen nuclei. Speaking of protons, there's an ongoing proton event following the October 28th X-class flare. It provided relativistic particles to the Earth system in only an hour, traveling at about 1/8 the speed of light, or about 23,000 miles per second. Pretty quick gas, making it into Earth's geospace. It hasn't subsided yet. We forecasted it would be there for days, and indeed it is. So here are the ionosphere absorption parameters, the prediction for radio blackouts. And you can see they're persisting here over Antarctica. It is spring down there. Antarctica got a higher dose of those solar protons than the northern polar region. You can see some ongoing radio blackouts there. Pretty much around the noon portion of the planet there, the noon polar region there in polar autumn. As we wait for those protons to subside, let's take a look at the real-time solar wind next. And there's a real-time solar wind slowly coming down from quite high levels here. We saw it reach all the way up near 650 kilometers per second yesterday. That's a high-speed coronal hole wind stream big time. Now subsiding, still over 500 kilometers per second, though. That is still an elevated solar wind speed. Solar wind density, 6.78 protons per cubic centimeter. Again, the solar wind velocity, 520 kilometers per second. The rest of the parameters pretty unremarkable there. KP index currently at 2. It's geomagnetic calm conditions for you new viewers. The KP index is a measurement of global geomagnetism. You can read more about it on the details tab from the Planetary K Index page. Next, magnetohydrodynamic pressure, modeled by the Space Weather Modeling Framework for the past 4 hours. We can expect a small reduction here in the pressure over the past 4 hours, but very minor, as it's been a slow ramp down of that coronal hole wind stream. This data brought to you by University of Michigan. That was the geospace. Here's the ground space. Ground magnetic perturbations, changes to Earth's B field known as geospace delta B. Keep in mind this model is in nanotesla. The last one is in nanopascals. This one is magnetic flux density. The other one is magnetohydrodynamic pressure. Like the last frame, this is 4 hours of data. We show it daily because people are overly frightened of a geomagnetic excursion. Don't be frightened of a geomagnetic excursion, folks. They're probably going on all the time. They're a little bit like climate change. In fact, maybe they're even associated. Continuing on, here's a diagram of the solar system. We're approaching a new moon, my favorite phase, as I'm a reverse werewolf. Please watch our previous videos if you don't know what a reverse werewolf is. Let's advance this 1 week. Here's where things will be in a week. A crescent waxing. That's your solar systemic forecast. And here's a star chart. We've got the ecliptic, which is the yellow line, and the galactic plane, which is the blue line drawn in. And as the sun goes from Gemini to Taurus, it'll cross the galactic plane. Please leave us a comment if that frightens you. We hope it doesn't. We also hope cosmology doesn't frighten you. I don't think there's anything to fear. Let's take a look at some cosmology stuff. One of the things you may fear is cosmic ray flux. It does seem to be associated with solar activity. It does seem to be associated with Earth's climate. Yeah, energy from space. Primarily in the form of the same thing we see from the solar wind, mostly hydrogen nuclei, also helium, also electrons, and the rest of the elements on the periodic table. Anyway, here's a 30-day chart from Apadity Neutron Monitor right here. And you can see there is a downtick over the past 30 days at Apadity. What about Barentsburg? A similar proportional downtick there at Barentsburg. Let's go farther south to Athens, Greece, to look at the Athens, Greece Neutron Monitor. And there you can see a downtick at Athens as well. Little downtick at Athens, Greece Neutron Monitor. How about Mexico City going even farther south? Also a downtick there. Now when we get to the Antarctican monitors, we're going to see some wild spikes, possibly cosmic rays that came out of Earth. But first, Oulu, Finland. So there's Oulu, and you can see Oulu has downticked over the past 30 days as well. When we look at DOMB Antarctica, we see a wild spike here late in the day on the 28th. Interestingly enough, if you think that's erroneous data, probably not, as DOMC Antarctica picked up the exact same spike. So that's interesting. That could be a cosmic ray that comes out of planet Earth. We've recently discovered that some cosmic rays do emanate from the planet Earth. Others come from stars within the Milky Way galaxy. Others come from outside the Milky Way galaxy. But there is a downtick at Oulu. And a little flatter environment there at Antarctica. So that's interesting. If you have a theory as to how cosmic rays come out of the Earth, let us know in the comments. I won't get into it in the daily space weather video. This cosmology segment was integrated. So cosmic rays are very important. They seem to cause clouds to nucleate and more. I'll just say and more. Did you know about the Viking landing in Canada approximately 1,000 years ago? Yeah. Well, isotopic ratios between carbon-12, the natural form of carbon, and the much rarer carbon-14 isotope tells us what cosmic rays were doing 1,000 years ago. So around the year AD 1021, rather, almost exactly 1,000 years ago, there was quite a large burst, most likely from the sun, where there was a big uptick in carbon-14 isotopes in living things like wood is a great example of that. If you want to read more about the last 1,000 years of cosmic ray flux, solar activity, etc., head to smAsho.com/forum. I'm just letting the article scroll here, so you can pause the video and read it if you like. Keep in mind those are recreation buildings, not 1,000-year-old Viking buildings. Head to smAsho.com/forum if you want to read more about cosmology, Earth and geophysics. If you'd like to post stuff, post away. It's completely free. You can even read the post without logging in. But if you want to post, you'll have to create a login. Check out our The Sun forum. If you click on that, you can find a thread in there entitled The Grand Solar Minimum. Yeah, there it is. Grand Solar Minimum. Huh? And go have a read about that. I haven't heard any of the, quote, Grand Solar Minimum community, end quote, mention this article. It talks about 1,000 years of cosmic ray flux and solar proxy data. So go have a read. smAsho.com/forum. You can also find our mission there. Yeah, our mission, where we advance the study of predictive phenomenon and not nonsense to attempt to do stuff like, save lives and resources and adapt no matter what the adversity is. So if you want to read about that, you can find that on the forum as well. smAsho.com/forum/mission. What about the sun's magnetic bubble? Yeah, some cosmic rays get through the magnetic bubble. Others are forced to align to the magnetic bubble's potential field surface source lines. Yeah, the same way they do when they reach the Earth geospace, most likely. The heliopause. We've only got 2 objects ever, man-made objects, that have left the heliopause, Voyager 1 and Voyager 2. And they're getting extra stellar space data now as a result. Turns out there's a quite a distinct area where the cosmic ray environment suddenly changes drastically, called the heliopause, where there is a extrasolar galactic interstellar wind, very similar to the solar wind, but it's an interstellar galactic scale wind instead. The heliopause, if you have theories as to how it's shaped, I think it's probably shaped like a croissant. But in any case, I'm going to let this article scroll as well. Today's Daily Space Weather video fortified with some fascinating cosmology articles. Next, talking about the Horsehead Nebula and some other nebulae here, like the Flame Nebula, which is this one down here. It's the astronomy picture of the day, apod.nasa.gov, if you want to go check it out. It's a great computer desktop, and it contains all kinds of spectral data. You've also got... So the Horsehead Nebula, first of all, is an emission feature. It's casting a shadow, basically, on this emission feature. So you've got a absorption feature here with an emission feature behind it. And that's hydrogen back there behind it. You've got the Flame Nebula, which is largely an absorption feature as well. Also over here, you've got NGC 2023. And over here, you've got IC 432, that reflection nebula. Again, a great computer desktop. The astronomy picture of the day. Let's pick a random number. It's 17, which coincides with a cataclysmic variable star here on the Neil Gehrels Swift-Bat X-ray Observatory, the Burst Alert Telescope, which monitors hard X-rays. It's Zeta Andromedae, a Beta Lyra binary, a type of cataclysmic variable. There are the hard X-rays of Zeta Andromedae over the past 16 years in the upper right, in the past 30 days. It's a bit of a naughty star. It's a bit of a naughty star, folks. It is a cataclysmic variable. It's bright across the entire electromagnetic spectrum, as you can see here under the photometric points. And if you want to read more about this yourself, head to the Neil Gehrels Swift-Bat X-ray Observatory, click on number 17. That'll take you to this page. Click on SIMBAD. And on the SIMBAD page, you can click on the CDS portal, which is where we are now. Let's take a look at it in some additional spectral wavelengths. This is visible light of Zeta Andromedae. And here's a Rosette X-ray image, this all-star survey, the all-sky survey, rather. There it is in X-ray. It's not a super bright X-ray source. Here it is in ultraviolet. That's the Galix. Pretty bright ultraviolet light source there. Here's the Pan-STARRS optical imagery, and you can see it's quite a busy area there. We're seeing all kinds of different wavelengths there, indicating that there's all sorts of refraction going on in the plasmasphere surrounding this cataclysmic variable. Looks great there in the high-resolution Pan-STARRS imagery. That does include bands I, R, and G. There's the Pan-STARRS bands Z and G. Great imagery there of Zeta Andromedae. And we'll close out this visual analysis with some infrared spectroscopy. There you go. There are the infrared emissions from Zeta Andromedae. Again, it's number 17 on the Neil Gehrels Swift-Bat X-ray Observatory transients page. And that's today's cosmology segment. We hope you enjoyed it. Make sure you check our playlists. If you haven't, youtube.com/smashamash/playlists. There are over 200 cosmology segments on the playlist. Let's check charging hazards. Surrounding planet Earth, we don't see any charging hazards at the moment. Things are slowly subsiding with that proton event. Here's the relativistic electron flux over the past year, reported by Solon.info. Here's the relativistic electron flux over the past 3 days, and we see an electron storm in the forecast. There you go. That can cause some communications breakdowns. You may see some satellites CCD baking out as a result of that. The charge coupled device shuts itself off to prevent being damaged if there is too much charging on the satellites, and that is a significant electron storm. I would agree with that forecast model. Next, we're going to show you the total electron content forecast, but first a diagram of Earth's Van Allen belts. Here's a total electron content forecast, and we're seeing a subsiding of the very high levels of electrons here around the equator, and a subsiding of the GPS anomalies over places like North America. Is it a result of the proton event going on? I don't really have any reason to conjecture about it. I'm going to let it play through a second time here. The total electron content forecast is showing you the entire air column worth of electrons from your GPS satellite down to your handset. Usually GPS errors occur around the equator at noon. When we see chaos in the Van Allen belts, we see something different than that. Things returning to a more normal state at the moment. Next, a diagram of the atmosphere to show you where the F layer is. The F layer of the ionosphere located about 300 kilometers of altitude. Here's an ionogram of that. So this is going to show you vibrational frequency here. Each color represents 1 million vibrations per second gradation. So red is 1 million vibrations, yellow is 2 million vibrations per second, etc. We'll also show you the anomaly map to show you how this fits in contextually on a 30-day basis. Certainly some high-frequency anomalies happening in the Central Pacific once again. There's a latest image from 9:15 Universal Time, and here's the anomalygram, departure or anomaly in megahertz from the 30-day median. And you see some low-frequency anomalies over the Indian Ocean, for example, shown in red. Some high-frequency anomalies in southern South America, low-frequency anomalies over the Central Pacific region. Let's bring up the latest image. There it is. It's 9:15 on the ionogram, 9:30 on the anomalygram. Let's do bonus features. And here come bonus features, starting out with the El Teide ground-based solar observatory. Hydrogen alpha imagery. Here's your latest intensity gram. Sunspot 2891, still beta gamma class as we record the video. Here's your colorized magnetogram. We pressed refresh. You can see these umbrae are very close together here. Still multiple field polarities there, both north and south pole oriented, still capable of producing significant flares. The rest of the solar disk, not so much so. Those are alpha class sunspots, I believe, by the end of the day. Next, the southern hemisphere. There you go. As sunspot 2887 sets, the X-flare producing sunspot. Here's the northern hemisphere. We've got some missing data there, it looks like, from the SDO, which is accounting for that jerking around. Don't worry, the sun did not lurch like that. Here's the imagery that we typically stream live on Twitch. This is the GOES 16 SUVI imagery. It auto-updates, so we can just stream this. Yesterday, we streamed the release of filament Pierre-Marie, which, as you can see, is no longer up there. It's out in the solar system, at least part of it. And here you'll actually see this happen. You'll see a little bit of a brightening right around here as that filament releases. Let's take a look at a different view. And the SDO browse data working out a little bit better here. So here's filament Pierre-Marie, and you're going to see it kind of spread down this way. And then there's going to be a little brightening right about here as that filament releases. And when the filament is headed directly towards you, it's very difficult to see them. There's very little contrast as that helium is quite diffuse. That's 304 angstroms. That's the daily space weather. Congratulations once again on realizing our channel exists, and may that solar wind be at your back.